Course 1, Lesson 81 has us doing math, or arithmetic, if you want to talk fancy. Using units of measure. What's an example of a unit of measure? Units of measure are like feet, abbreviated FT, or inches, centimeters, meters. First of all, which one's bigger, feet or inches? Feet, of course, and meters are bigger than centimeters. So the number, if these are going to be equal to each other, the number is going to be bigger over here by the centimeters, aren't they? How many centimeters to a meter, by the way? Let's try centimeters to meters. If I have 1 meter, 100 centimeters. I don't know why I doubted it. I figured it was. It's millimeters, that's 1,000. Centa means 100, so that's how you know. 100 centimeters is 1 meter. There you go. Bigger number over here because you need more centimeters to get to a meter. But feet and inches, the US system is a little bit trickier. If I have, let's say, 1 inch. No. I don't like that. 1 inch is going to be a decimal feet because feet are bigger. If I have 1 foot, those are the bigger measure. It's going to take more inches. I'm going to have a bigger number than 1 for inches. It's 12 inches to a foot. Okay? So we're going to add and subtract measures today. And when you add and subtract, the units stay the same. Okay? Add, subtract, units stay same. Later, we're going to get to multiply, divide. You're going to do a little bit of that too. That's where units change or end up different. Okay? Keep that in mind. Let's get to it, huh? For example, 2 feet plus 2 inches. 2 feet plus 12 inches. Two things here. Remember that the units have to stay the same when you add and subtract. The problem in this one, the units aren't the same to start out with. So we need to make them the same. It's important that they are the same when you add, and then they'll stay the same. The add-ins will stay the same in the sum. So you have to make a decision. Either change feet to inches or change inches to feet. Which one do you think would be easier? I think feet to inches. So change this number into inches. Feet, 2 feet would be 24 inches. Because 12 inches to 1 foot, if I've got 2 of them, you got to double your 12. Now I've got inches to inches, right? Because we have the 12 inches to start out as one of our add-ins. And when adding and subtracting, the add-in unit and the sum unit stay the same. 24 plus 12 is 36 inches. I actually think, looking back, that turning 12 inches into 1 foot would have been pretty nice too. Now you're just doing 2 plus 1 is 3. Feet to feet. Now, you might say, here my answer was 3. Here my answer was 36. Who's right? Both are right, as long as you label it right. Those are equal. And it didn't say we had to show it one way or another. It just said add. So you get to pick. A little choice today. Now, like I promised, multiply, divide, you get something different. When we find the area, we have to multiply, right? And if you're using units of measure, which you usually are with area of figures, it might have centimeters, like 2 centimeters going up and 3 centimeters going across. And when you multiply those, area, 2 times 3, you've learned that the units do change. Instead of just centimeters, they are now square centimeters. And that's because a centimeter looks like this. But it's a very different unit from a square centimeter, which looks like this. they're so different we can't use the same units of measure. This is for length. You could represent it with just a little line like on a ruler. Square is 2 dimensions and it's area. So it changes it to a different unit of measure. The unit of the product is a different unit because we multiplied factors. When we multiply 2 centimeters by 3 centimeters, you can actually think of it as not only 2 times 3, but centimeters times centimeters. Yeah. And when you do centimeters times centimeters, it's square centimeters. You can use the SQ, or we learned last time you can use the little 2 floating up above. So let's try multiplying 6 times 4 if they're both feet. Okay? We don't have to change, we don't have to convert like we did with the add subtract, but we will convert with the label in the end. 6 feet, if you want to picture it as like a rectangle, times 4 feet. Oh my. Sorry about that. 6 feet times 4 feet. You can picture it this way if you'd like. And remember, area, multiply these, you get a square label. 6 times 4 is 24 square feet. Cool? Sorry if I'm going a little slow. Thanks for hanging with me. We're almost done. What about dividing? For example, if we had the 21 area that we just found, actually no, we found 24. But what if the area was 21? And we wanted to find out, well, what was a width? If we know the length was 7, we could actually divide it and find that the width was 3. Now when you divide the units too. We divided an area measure, square centimeters, by a length measure, 7 just centimeters, not squared. So you can actually blast that out and show it's centimeters times centimeters, and you can do some crossing out. Make this a 3 and take out some centimeters to leave a centimeter here. Basically, if you divide 21 centimeters squared, an area measure, by 7 centimeters, which is just a length measure, a different kind, you can divide those. It's not adding or subtracting, so it's okay. And the answer is 3, just plain centimeters. Width, length, area for, let's say, this rectangle. You could show it like that. Divide 25 miles squared by 5 miles. If you want to show good work here, you could write out your 25 and then show the miles squared like this. Miles times miles, and just do some basic canceling here. 5 goes into 25 5 times and 5 1 time. And then cross out 1 mile. You end up with just a unit of length, 5 miles. If the units are different without being squared, we can't make that any smaller. So if it's not miles squared divided by miles or gallons squared divided by gallons, I've never heard of gallons squared, but if it's completely different letters, gallons and miles, and you can't divide those, then you just show miles over gallons. Okay, so it's actually miles per gallon is what that means. All right, keep that in mind in case you get one of those in the practice. We got to wrap this up. Why don't you try A, B, C, and D? They're all just a little different, and I think you can do them quickly enough. Go ahead.